Hello, everyone. This unit that we're starting out with is called Modern Atomic Theory. And so you're probably wondering, well, then why in the world is there a picture of this ancient person on the screen when we're talking about modern atomic theory? And that's because we are going to first look at a quick review of some of the ideas that helped us evolve the current modern theory that we have today. So hopefully this will all be review, and we're starting with John Dalton and his atomic theory from about 200 years ago. And here I just wrote out the highlights of his theory. And the first one, he said elements are made of atoms. And that sounds ridiculous to us now because it's pretty obvious, but it wasn't necessarily obvious 200 years ago. The next couple of ideas, that all atoms of a given element are identical, and that atoms of one element are different from those of another element, those are really important ideas. We know that, for example, the element sodium, we know that all sodium atoms are the same from one to the next. They belong to that element. We also know that a sodium atom is definitely not the same as a calcium atom. They are different. So those were also important ideas. The next idea right here is the law of constant composition. That's a really important idea. Dalton came up with the idea that atoms combine to form compounds, and that a given compound has the same relative numbers and types of atoms. So, in other words, say we have a water molecule. There's our little water molecule. We know that the next water molecule also has 2 hydrogens and 1 oxygen, just like the first. And if we have another water molecule, it will also have 2 hydrogens and 1 oxygen. If it doesn't, if, say, we have 2 hydrogens and 2 oxygens, then it is not water. It's hydrogen peroxide. So the law of constant composition was an important one, as well as the next one here, that atoms are not created or destroyed in a reaction. They are just regrouped. So we don't cut them in half or do strange things to our individual atoms. They simply break bonds and bond with other atoms and regroup in a new way. And that was a new idea for them. Here is J.J. Thomson, our next scientist that we're going to talk about. He came along about 100 years later, and he was doing experiments and found that some atoms that he had were repelling tiny negative particles that he was bombarding them with. And he wondered, what does that mean? He couldn't quite figure it out. Maybe that's why he looks so concerned in this picture. He decided that perhaps there were little tiny negatively charged particles. He decided to call them electrons, and they must be present somewhere in this atom in order to repel his tiny negative particles that he was throwing at them. So here he developed an idea, and it was later termed a plum pudding atom, where he thought perhaps there's a big mass of positive charge, that's the pudding, and then there are little tiny negative charges sprinkled throughout the pudding, and called it a plum pudding. Those little negative charges he called electrons. And so, although we recognize this is not how the atom looks, he did contribute in that he gave us the idea of the electron. Our next scientist, and the last one we're going to discuss, is Ernest Rutherford. And I didn't put a picture of him here. I thought actually his experiment was a little more interesting. And here it's called the gold foil experiment. You've probably heard of that, and you'll hear of it again, I'm sure. He had a real interest in alpha particles, and he projected these alpha particles from this source here at a piece of gold foil right there. And the gold foil was very thin, and this sort of the metal piece surrounding it right there is a screen that recorded the alpha particles when they hit the screen. And when he projected the alpha particles at the gold foil, he found that most of them just went straight through. However, there were some that did not. Some of them deflected at great angles or even reflected off of the gold foil. And again, he scratched his head and wondered, wow, what is happening here? This led him to this model of the atom here, where he had a nucleus, which this was a new idea, obviously, very different from our plum pudding atom. And this nuclear atom, he proposed, had a dense center of positive charge. Later on, one of his colleagues worked with him, and they developed the idea of a neutron as well. And this nuclear idea was very new, very different. He still wasn't entirely sure what those electrons were doing, and that was an unanswered question of his that he contemplated. What are the electrons doing, and why don't they collapse into the nucleus, and what is going on there? But this model that Rutherford came up with was the best at the time, and was certainly a new thought and a new way of thinking about the atom. So that's the end of our lesson today, and if you have aspirations for achieving the advanced proficiency, here are a few questions. You can pause the video and just look at some of these and see if some of them might be of interest to you, some research or some extra work that you might do to get an advanced proficiency score. So thank you very much, and I'll see you in class.